Hey, welcome. So when you think of a modern laboratory, you probably picture incredible discoveries, right? New medicines, groundbreaking materials, all that amazing stuff. But labs are also filled with invisible dangers, everything from highly reactive chemicals to powerful electrical currents. So what is it that keeps the brilliant people working in these spaces safe?
What's the secret system that manages all of that risk? Now, you might just think it's a huge list of don'ts, but honestly, it's way more than that. It's a whole science in itself, built on layers and layers of protection.
You know, just like a pilot runs through a pre-flight checklist, a scientist has a system. And for good reason. Because in a high-stakes environment like a lab, where one tiny mistake could have huge consequences, safety can never, ever be an afterthought. It has to be a carefully designed, proactive system.
Okay, so how do you even begin to manage dangerous you can't always see? Well, you do it with a framework of very visible, very clear rules. And this isn't just about using your common sense. We're talking about a formal safety structure, one that's actually mandated by federal organizations. Let's break down what that structure actually looks like.
Right at the top, you've got OSHA. That's the Occupational Safety and Health Administration. Their laboratory standard makes it a requirement for every single lab to have a written chemical hygiene plan, or a CHP. Think of the CHP as the lab's custom safety playbook, and to make sure that playbook is actually being followed, each lab has to appoint a chemical hygiene officer. So what this means for the scientists on the ground is that there's a clear, legally required system in place with a specific person whose job it is to oversee their safety.
Let's start with maybe the most common hazard out there, chemicals. A modern lab is kind of like a chemical minefield, and getting through it safely takes more than just being careful when you pour something. It all starts with smart storage.
Okay, so this right here highlights a mistake that on the surface seems totally logical. Storing chemicals alphabetically sounds super organized, right? Well, it can be incredibly dangerous. Why? Because putting, say, acetic acid right next to acetaldehyde is a recipe for absolute disaster. A tiny leak could cause a fire or release toxic gas. And that's because lab safety isn't about the alphabet. It's all about chemical compatibility.
And this table shows you exactly what I mean. You have to separate chemicals into these compatibility groups. See, storing acids next to bases can cause some seriously violent reactions. Putting flammable liquids anywhere near oxidizing acids creates a huge fire risk. And liquid oxidizers? Whoa. Those are so reactive, they basically need to be kept away from, well, almost everything. This isn't just about keeping the shelves neat. It's about preventing a dangerous chain reaction.
All right, so we've talked chemicals. Now let's switch gears to another invisible threat that powers every single lab out there, electricity. It's absolutely essential, of course, but it comes with its own set of dangers that are really easy to misunderstand. Here is a super important point that a lot of people get wrong. We always hear about high voltage being dangerous, and it is, but when it comes to an electrical shock, the real killer is the current, the amount of electricity flowing through your body. That's measured in amps.
In this table, it is genuinely shocking. I mean, look at how small these numbers are. Just 1/1000th of an amp, and you'll feel a tingle. But once you get between 6 and 30 milliamps, you hit what's called the let go threshold. That's the point where your muscles contract and you physically can't let go of the wire, which makes the shock even worse. And 10 amps, which is less than what most wall outlets can push, can cause cardiac arrest. It's terrifying.
This brings us to a really common piece of lab equipment and a really common mistake. A basic power strip is not a surge protector. All it does is give you more outlets. It offers zero protection from a power surge, which can fry expensive equipment and even start a fire. A real surge protector has an internal breaker that'll trip, and here's the most important part, neither of them ever should be placed inside a chemical fume hood. A tiny spark in there could ignite flammable vapors.
So we've covered the environment and the equipment, but what about the most important and vulnerable thing in the lab? The person. And that's where the most direct layer of protection comes in, personal protective equipment, or PPE.
This right here is the bare minimum, the absolute non-negotiable baseline for anyone anytime they step into a lab. A lab coat protects your skin, protective eyewear shields your eyes, and then long pants and closed-toe shoes. This is your personal armor against all the little splashes, spills, and impacts.
So, you've got your safety glasses on, you're good to go, right? Well, not so fast. Because PPE is definitely not a one-size-fits-all kind of deal. You have to match your protection specifically to the hazard you're actually dealing with.
The best way to think about it is like leveling up your defense. Your basic safety glasses, they're great for stopping something solid, like a flying particle.
But if you're working with liquids that could splash, you've got to upgrade to goggles. They create a seal around your eyes. And for the really high-risk stuff, like pouring a lot of a corrosive liquid, you need a full face shield, and you wear that over your goggles. The main takeaway here is simple. Your protection has to match the risk.
You know, we've talked about these big safety systems, invisible dangers, and personal armor. But all of it, every single bit, rests on one simple foundational principle that gets overlooked way too often: good old-fashioned housekeeping.
I mean, this quote really says it all. A cluttered, disorganized lab isn't just an eyesore, it's actively dangerous. Poor housekeeping is a direct cause of accidents, everything from tripping over a box to not being able to reach an emergency eye wash station in time. And the pillars of good housekeeping are so simple, but so critical. It means access to emergency equipment like showers and eye washes is never blocked. It means aisles and exits are always clear, and chemicals are never ever stored on the floor. A clean, orderly lab isn't about looking professional. It's a powerful and active form of preventing accidents before they ever happen.
So after all this, after discussing all of these systems, rules, and different types of gear, it all comes down to one final, really important question. With all the amazing technology and protective equipment we have today, what is truly the single most important piece of safety equipment in any lab?
In the end, it's you. It's the person. All those chemical hygiene plans, the protective gear, the storage rules, they're just tools. The ultimate safety device is the well-trained, focused, and conscientious scientist who actually understands the risks and knows how to use those tools the right way. Because ultimately, safety isn't just in the system, it's in your mindset.